Hello chemists, and welcome to a video where I explain how to solve problem 6 of the free response section from the AP Chemistry 2016 exam. In order to complete this problem, you will need to have background knowledge of reversible reactions, solubility rules, equilibrium K and Q, molarity, complex ions, and limiting reactants. You don't necessarily need to know about complex ions, but it is nice to know about why this reaction would even form. So we are given the reversible reaction Ba2 plus EDTA4- is Ba-EDTA2-, where EDTA4- is the abbreviated form of C10H12N2O8-4-. We are also given an example where we have 50 milliliters of EDTA at a concentration of 0.3 molar, and it is mixed with 50 milliliters of BaNO3 2- with a concentration of 0.2 molar to produce a 10 milliliter solution. Well, what this means, this right here, the 0.2 molar of BaNO3 means that there is also 0.2 molars of Ba2+, because BaNO3 dissociates into Ba2 plus 2NO3 minus due to the solubility rule that every compound with NO3 always is soluble in water. And Part A says to determine the concentration of BeDTA2- in the 100 milliliter solution, given the value of K for the reaction, and it says to justify your answer. Well, because they said considering the value of K, we have to include K in this answer. So K is very, very large, meaning that the products there is going to be more products than reactants in equilibrium, because of K is concentration of products, which is Ba-EDTA2- over concentration of reactants, which is Ba2+ times EDTA4-. Because K is so large, that must mean that the concentration of Ba-EDTA2- is a lot larger than the combined multiplied concentrations of Ba2+ and EDTA4-. What that means is that the reaction will basically go to completion if it is at equilibrium, to reach equilibrium. So for part A, we need to say, because K is very large, reaction will go to completion. Now that we have that figured out, we can just treat this as a normal one-way forward reaction with reactants going to products. Now all we have to do is to find the concentration of the Ba-EDTA2-. And to do that, we have to find which reactant is limiting, if there is a limiting reactant at all. So we see that the volumes for each are the same, however the concentrations are different. But we also have to account for the fact that there is a new total concentration of the solution, and we have to find the new molarities of each of the reactants. So to do that, we have to use the formula M1V1 equals M2V2. For Ba2+, we say that 50 milliliters times 0.2 molar equals to 100 milliliters times M2. And when you solve that, M2 is equal to 0.10 molar. Next we have for Next we have it for EDTA4-, which is 50 milliliters times 0.3 molar equals 100 milliliters times M2. And M2 is equal to 0.15 molar. 0.15 molar is more than 0.10 molar, which means that Ba2 plus is limiting. Basically, the concentration of Ba2 plus when first mixed but before any reaction actually occurs, also I'm sorry about the shadow, I can't really do anything about that, is 0.10 molar, and it is the same as the concentration of Ba EDTA 2 minus, sorry. And so we can just say that Ba EDTA 2 minus is 0.10 molar. And that's it, you're done. That's it for part A. The point breakdown of this would be to say that Ba2 plus is the same as BeDTA2 minus before any reaction actually occurs. And the second point would be awarded if you found the correct concentration with the appropriate calculations. So this was a 2-point problem. And now we move on to B. So for part B, the solution is diluted with the total volume of 1 liter, and they are asking how the number of moles of Ba2 plus were affected. They also want an explanation since they said justify your answer. Well, this is where we have to find Q. Q is the same thing as products over reactants. And the products this time are each cut by 10 times because the solution is multiplied by 10 times. And using the formula M1V1 equals M2V2, we can kind of generally understand that the products will become 10 times smaller without having to do all these calculations. So we can just write that 1 over 10 Ba EDTA 2 minus over 110 Ba2 plus times 110 concentration of EDTA 4 minus the equals to Q, and the 110s cancel out, and we have 10 times Ba, concentration of Ba EDTA 2 minus over concentration of Ba2 plus times concentration of EDTA 4 minus. Well, K is that, so we can just say that Q is 10 times K. Wow. Well, since Q is so much greater than K, that means that there's a lot more products, because Q is greater than K, that means that there are more products than reactants when the solution is diluted, meaning that the reaction will move towards the reactants. To reach equilibrium. Because the reaction goes to reactants to reach equilibrium, that means that there will be more moles. There will be more moles of Ba2 plus than B4. And that's it, you finished the question. This part is also a two-point problem, 1 point is earned for stating that the number of moles of Ba2 plus will increase. So we have 1 point for that. And 1 point is earned for a valid justification. So the entire process is a point. So this is how you solve number 6 of the free response from the 2016 AP Chemistry exam. And I hope that you found this helpful. Now that we have that figured out, we can just treat this reaction as a one-way forward reactant to product reaction. The reactants, nope,